So we're going to determine if the following are perfect square trinomials, and if so, we will factor them. Let's start with part A. So to determine if it's a perfect square trinomial, let's look at the first term. What squared is x squared? Hopefully you just said x. And then what squared is 49? Hopefully you said 7. So for our purpose, A would be x, B would be 7. Since this is a minus, then we need to see if we have the format ax squared minus 2ab plus b squared. So that means we need to check, does the inside have the format of 2ab? So do we have 2 times our a is x, our b is 7? Does 2 times x times 7 make 14x? Yep. So because of that, we do have the format of ax squared minus 2ab plus b squared, which means this does factor as, let me write up the formula up here, this does factor as a minus b quantity squared. So we would say x, because that was our a, minus 7, because that was our b, quantity squared. Remember, whatever this sign is this sign. So part A was a perfect squared trinomial. Let's try part B. What squared is x squared? X. What squared is 9? 3. Does the inside have the format 2 times a times b? Does 2 times x times 3 make 6x? Yes. Good. So that factors as x, keep the sign, plus 3 quantity squared. Part C. What squared is x squared? X. What squared is 12? Wah, wah. Sadly, we'd get into something called the square root of 12. 12 is not a perfect square. So C is not a perfect square trinomial. If you still had to factor C, you would, just by thinking about what multiplies to 12 and adds negative 7, and hopefully you would say x minus 3, x minus 4. But it's not a perfect square. Oh, that's a non. Nailed it. So whatever makes the perfect square at the ends are your a's and b's respectively. And then once you have those, check the inside, the 2ab.